All right, now that we've gone over an overview of FiftyOne, installation, basic concepts, and how FiftyOne structures its data, it's time to get hands-on. In this portion of the workshop, we're going to be working in a VS Code notebook. So you can work with FiftyOne in any Python process, Python interpreter, you can work with a Jupyter notebook, you can work from the command line, but in this particular workshop, we're going to be using a VS Code notebook just to show you one specific way of doing it. And we're going to walk through how to work with the dataset and model zoos in FiftyOne, how to use the FiftyOne app, how to inspect a dataset, and creating and saving views, the logical pipelines of operations that allow you to filter your data. There's so much that you can do with FiftyOne. This is only going to scratch the surface, but I hope that this gives you the tools you need to start working with FiftyOne. Whenever we work with FiftyOne, the first thing to do is to import FiftyOne. Now, what we recommend is to use the alias FO whenever you are importing FiftyOne. That way you avoid a lot of the cumbersome nature with very verbose language in Python. So the first thing we'll do is we'll import FiftyOne as FO, and then we can print that out to see that it worked correctly. There you can see the location where the FiftyOne library is on my particular computer. The second thing we're going to do is we are going to import the FiftyOne Zoo. It's a submodule within FiftyOne that's going to give us access to datasets and models which come pre-packaged and ready to go with FiftyOne. So here we will import the FiftyOne Zoo as FOZ. We can print that out as well. You can see it's a submodule within FiftyOne. And the thing that I recommend to people getting started with FiftyOne is to look at the datasets and models that are already in FiftyOne's dataset and model zoos. And it's very easy to do with the list zoo datasets and list zoo models commands. So here we're just going to run FOZ FiftyOne zoo.list zoo datasets, and we get this list out that has a bunch of datasets that come ready to go with FiftyOne. We can do the same thing with models. So list zoo models. And we see we get a very long list here. Some of them are in PyTorch, some of them are TensorFlow. You can see the model architecture and the dataset on which it was trained. You can also filter a lot of these by the specific task. So if we wanted to filter for image datasets, we could do that. If we wanted to filter for detection datasets, we could do that. And the tags that you can filter by are actually available in the FiftyOne model zoo and dataset zoo documentation online. So we pass in these tags, and there's a syntax for doing that. You can pass in a bunch of tags and say you want any of them or all of them. But in this case, we passed in a detection tag, and we see this list of datasets that support detection. And we can load one of these. For instance, in this case, I'll just load the Cocoa 2017 dataset by just passing that name in to the load zoo dataset method. And we can specify the split that we want to load and the number of samples. So we can say, I only want to load 50 samples from that dataset. And in this case, I already had the data downloaded, so it's just going to load the data in the appropriate format. And then we can inspect this if we want to. And we're going to get into that inspection process shortly. But here we can print it out, and we can see the name of the dataset. So it named it with validation split and 50 for the number of samples. It has media type image, 50 samples, and this persistent property, which is false in this case, means that changes we make to this dataset will not be persisted to disk at this point, but we can change that very easily. There's a lot more, we'll get into that shortly, but the easiest place to get started is the Quickstart dataset. And FiftyOne has datasets for Quickstart on a variety of tasks. And if we go back up to the list zoo datasets, let's get rid of the tags part and just print them out again. We can see we've got a Quickstart dataset, which is the one that we're going to be using. We have a Quickstart geo dataset, which is an easy way to get started working with geolocation data associated with images. Quickstart groups, so you can start working with grouped datasets with different types of media, and videos, which we're also going to load in a moment. But for us, we're just going to start with Quickstart. So here, I'm going to get rid of this. Okay, here we're going to load the Quickstart dataset by running foz.loadzoo_dataset and passing in the name Quickstart. And in this case, I already had the Quickstart data downloaded, so it loaded that data in, and there are 200 samples, and then I can see the data that was generated. So it's Quickstart, image, 200 samples, not persistent, and then a bunch of other stuff. The same syntax works for models. You can load a model from the model zoo with the load zoo models command. And in this case, we're going to load a clip model, which is a multimodal model, supports both images and text. And we can load that in by passing the name of the model into this load zoo model command. And going up, we can again see our list of these models that we have right over here. And if we scroll up to the very top, we can see this right here. So if we go down and we load this model, then we can print out the model, and we can see in this case it is a torch model as specified by this torch piece of the zoo model name, and it's implemented as a 51 model, which is essentially a 51 wrapper around the torch model. Now, we're going to get into this shortly. We're not going to go too deep into evaluate detections or evaluation methods in FiftyOne, but just to make our life a little bit more interesting when we go to visualize and inspect the data, I'm going to run this evaluate detections command. And printing out our data set once more, and printing out our data set, we can see if we look at these additional properties, we have a ground truth label field. We can see it is of type labels.detections. And we have a predictions label field of type labels.detections. So we're going to evaluate our predictions detections with respect to our ground truth label field of detections. And we'll just save these results with an evaluation key eval. Again, we're not going to get too deep into this, but this is going to make our lives a little bit more interesting when we go to visualize things. So let's run this command, and it's going to do an evaluation routine. And on our samples, it will make a note of which predictions are true positives, false positives, and so forth. We can filter through this data at will. Okay. All right, now we're ready to explore the FiftyOne app. The FiftyOne app makes it easy to visualize and filter your data via a UI. And it's very easy to start working with the FiftyOne app. All you need to do is launch a session of the FiftyOne app with the launch app command. You pass in the dataset object. You can also pass in a view if you'd like. And you don't need to pass in any arguments if you don't want to after that. But in our case, we're going to pass in auto equals false, because if we did not do that, then the app would launch in the output of this cell in the notebook. But in our case, by passing in auto equals false, we're saying don't launch the app in this cell, but create the session object, and then we'll be able to access that in our browser. So let's do that. All right, now we can inspect this session. So we have the Quickstart dataset of type image, as we had before, 200 samples, and we have 0 selected samples, 0 selected labels, and we have a session URL. So let's click on this session URL. And here we go. We can see that at localhost :5151 for FiftyOne, we have the Quickstart dataset. If you have other datasets, as I do, you can actually filter through them and choose the dataset that you'd like there. Now, what can we do with the FiftyOne app? Let's start going through. The first thing that you might want to do is to just filter through, just to navigate through the samples in your sample grid. So you can either do this using 2 fingers on your keypad or your mouse pad, or you can use the sidebar. You can look through the samples and it will continually refresh with more samples. You can also click on a particular sample. So let's click on this sample and open the sample modal. And now we can see in higher resolution this particular image. We can also see a bunch of attributes on it. So we have a bunch of these labels. In this case, there's a lot of person labels, and these are a lot of predictions. So this prediction algorithm that was run was very low confidence, or it gave a lot of poor predictions. So let's turn those off, which we can do by just clicking on this checkbox over here. And what we see is then we only have 2 labels, 1 person and 1 horse, and these are both ground truth in their ground truth label field. We can hover over a particular label to see properties of it. So we see it has the label horse. It has an area in this case. It was evaluated as a true positive. So one of the predictions actually did coincide with this. And then there's some other things. We can also look at the predictions. If we hover over one of them, we can see as well there's other things. There are other properties associated with it. We can inspect other attributes. So we can inspect the tags, and we can see that there is a validation tag on this particular sample, and indeed on all samples in this particular dataset, because this dataset is a subset of the COCO validation split. There's also this metadata field, which has a bunch of subfields, and none of these are populated at the moment, but we can populate those. So let's actually do that, and let's see how easy that is to do. So if we have our dataset, we can run compute metadata, and that will compute the metadata. Let's go back over to the app and refresh. And now let's go back over here, and we can see these metadata fields have filled in. It's got things like the number, the size in bytes, the MIME type, the what type of image it is, and the metadata width and height, as well as the number of channels. We can also filter through all of these attributes in the sidebar. So instead of just turning them on and off, we can still turn them on and off. We can turn on and off whatever we'd like, but we can also filter by them. So let's say we want to open this up and filter for, as a start, only ground truth labels of cars. Now we see all of the images. In this case, we can see select detections with this label. So we are seeing only the ground truth detections that were labeled as car, but we could also select samples with this label. And now we're just going to see all of the detections in the samples with that particular label. Let's reset this. We can see the file path. Each of these images has its own file path, and these file paths need not be unique. If they are unique, then you can actually query for that particular file path. You can index your samples by that file path. If not, then you have to be a little bit more clever with the way that you do it. Each of these samples also has its own ID over here. And then we've got these true positive, false positive, and false negative. So all of these true positive, and false negative fields, as well as the labels on the particular detections, were generated when we ran evaluate detections. Not going to go too deep into that, but we can filter our samples by the number of false positives, false negatives, and true positives. So let's say we want the samples that have, in this case, let's do this between 0 and 10 true positives, or we can get the ones that have a lot of true positives and very few, there's none that have that many false negatives. We have a few that have just a few false negatives and a lot of true positives. We can reset these as well. So if you notice there, I combined filters. I filtered on multiple attributes at the same time. Let's actually do that again. Let's filter on a few more. So we've got this uniqueness field, which in many datasets you have to run a compute uniqueness algorithm from the FiftyOne brain in order to compute that. But because we're on the Quickstart dataset, this comes pre-computed. And so let's filter for unique images. And let's look at images that have just a few true positives. Just a few true positives. And now we have this subset of our data. And we'll talk more about subsets and views of the data in a moment, but for now, we can still do the same thing where we look at in the modal any of these. We can also select them and do things with that selection. Or if we wanted to, we could take all these filters that have been applied, and we can use this icon over here to convert the current filters into a view stage. And when we do that, we see the view bar up top populates with this match condition. And if we inspect this, we can see what's going on under the hood, what the actual filter is that's being applied. Now, we could then, if we wanted to convert this view stage into a saved view, we could save it by using Command S and then going forth from there. But we're not going to do that at the moment. We can clear this particular selection by, if we want to clear one stage, we can click the X next to that particular stage, or we can click the X at the right-hand side of the view bar to clear all of the view stages. And now we're back to the entire data set. Okay. Just a few more things I want to show you here, and then we will get back to Python code. All these buttons that exist right here, some of these are pre-built buttons. So there's something like the Embeddings panel, which right now we actually don't get anything for because we haven't computed embeddings in our data. We can also access these via this plus icon. And then we can access, for instance, the histogram panel. And we can look at histograms by labels or by, let's look at labels by here. This is here. This is what we want. We're looking at the label fields, and we're looking at the ground truth detections label. And we can see the count for person, for kite, for car, for all of these different things. And similarly, we can see one for predictions way down here, as well as other histograms. And you can access all these histograms and all of this data via FiftyOne aggregations as well. Now, what if we want to be looking at this at the same time as we're looking at our sample grid? We can use these two icons over here to split our view. So let's say we want to look at this one with a vertical split. So let's go back to the view that we're looking at and interested in here. Now we can look at the entire histogram and look at all the samples in our sample grid at the same time. If we want to look at more samples, we can also use this little slider over here, and we can make this smaller. So we're looking at more samples that are much smaller, or we can make them really big. We can also change the layout. We can move this down or up as we like. So again, flexibility and customizability. And speaking of customizability, some of these icons are icons that I added in myself using FiftyOne plugins. If you want to know more about plugins, you should attend our FiftyOne plugins workshop, which will be happening very soon. Okay, that's good for the app for now. Now it's time to go back and inspect our data in Python. All right, so as we've done before, we can print out the data set. And we computed our metadata already. We can inspect properties of the data set as well. So using the dot syntax, which you're probably familiar with from a lot of Python applications, you can inspect properties of the data set. For instance, the file path. So let's look at data set. Or not the file path, let's look at the tags on the data set. And in this case, the data set has no tags. We can also add tags. So let's do tags.append, and let's do my tag. And now let's look at tags again. And we have a tag there. There are other things as well. So there's, for instance, the media type. So if we did dataset and we looked at the get field schema, we can get a sense for what is going on and what the types are of all the things in the dataset. Okay, but what if we want to go beyond just looking at dataset properties and we want to look at individual samples? We can do that as well. And we can use the same syntax. So to make our lives easier, let's start by looking at the first sample in the dataset. And that's very easy to do by using the first method. When we do this, we get this printout with if we scroll to the top of this very long list of data, we have a sample object. And this sample object comes with a bunch of properties. It has an ID. It's got a file path. It's got all this other stuff which we saw in the app. So there's a seamless connection between the FiftyOne app and the Python software development kit. And you can manipulate that and modify that however you see fit. We can also instantiate a sample with this. So let's create a sample, and then we can refer to that. Now, we can also do the same with, let's call this first sample. We can also do last sample. So FiftyOne also has a last method. So last sample is equal to dataset.last. And we can also take a random sample from the dataset. So in this case, we're going to take a random subset of length 1 and then just get the first one in that. Now, we can get properties of these samples using the same dot syntax. So if we want to get the sample file path, this is for this random sample that we just took. We can also look at the first sample file path. And we can see these are not the same. They're different samples. We can do the last one as well. We can look at the sample ID. So let's look at the ID of the first sample. And we can use these IDs to retrieve this sample from the dataset. So let's see that in action. If we do dataset of, and let's just paste this ID in here. And we get a sample out. If we scroll to the top here, again, we will see a sample. If your dataset has unique file paths, you can also use those file paths in order to uniquely retrieve samples. So in this case, we do have unique file paths. So let's do that. Let's take this file path and let's just feed that in over here. And we get another sample object. Awesome. And the same way as we were able to look at the dataset tags, we can also look at the sample tags right here. We can also go deeper than this and look at subfields. So what we're doing here is by using the dot syntax, we are accessing and modifying, if we want to, fields on our samples. But we can also modify fields within subfields. We can access fields within subfields. So if we look at our sample, in this case, let's go back over to the app and see what the structure looks like of an individual sample. So I'm going to close this down. And let's look over here. We've got these ground truth and predictions labels. So let's access the ground truth. Ground truth. We can get this field out. And this is a detections field, as we would expect. And within that, it has a list of detections, each of which is its own label, which has an ID, tags, a label for the class, and then a bounding box. We can go deeper, though, and we can look at the detections within this. And let's look at this as a list here. So let's just get the first element of this list. And now let's look at the label of this. It's a person. Or what about the bounding box? Boom. And this is in relative coordinates. You can also access things via the dictionary type syntax. So let's take this away, and instead of the dot, we'll just use the dictionary syntax, and we get the same thing. You can mix and match these however you like. All right, now that we know how to inspect our dataset and how to inspect samples in the dataset, let's talk about understanding the data a little bit more deeply and looking at aggregate statistics about the dataset. As I mentioned in the earlier part of the workshop, FiftyOne supports all of your favorite aggregations. We saw some of those in the Histograms panel within the app earlier. For a full list of supported aggregations, you can actually just query FiftyOne. So if we have our dataset, we can use the list aggregations method, and we can see all of these supported aggregations here. So we can apply these to base level fields or to nested fields. So let's start by looking at something simple like values. Let's do dataset.values, and before we actually plug anything in, let's use the question mark and we can get the signature. What does this do? And this question mark applies to aggregations, to view stages, to a lot of other things in FiftyOne. It's a huge help in understanding how things work within FiftyOne. So you can pass in a field or even an expression that goes into a field that allows you to filter the contents of that field or manipulate them. And then it has a bunch of other things. So let's see an example here. In this example, we're looking at the values of just some field. Okay, so let's, for instance, take the values of the file path. And we get out this list. And the length of this list is 200, because that's the number of samples in our data set. We can also look at, like, for instance, the uniqueness. So let's look at the uniqueness over here. In this case, we get numerical values. But we can also filter within subfields. So for instance, let's say we have let's look at our fields again. We have our data set. So we have our data set, and it has this metadata field. And now let's look at that metadata field. So let's look at the first sample, and then let's look at the first sample, and let's look at the metadata. We can see that it is this embedded field with width and height. So let's look at the height on that. Okay, so now we can use the same syntax to get the values of height across the data. Instead of passing in a single field, we can pass in this expression over here, this subfield. So notice the sample part is gone because we're getting the values across the entire data set, but we're still keeping the dot syntax. And we get this list of values. And this will be 200 values again. Now, if we don't want to get just values, let's say we want to get something like the mean. We can do that as well. So the mean works not just for outer properties, outer fields, but also for inner or nested fields. So by the same token, we could do the mean for the uniqueness. We get out a value there. Let's go back up to our list of aggregations, or let's actually just print it out again. Dataset list aggregations. We can see this list over here. Okay, what about bounds? Let's look at the bounds for uniqueness. And the bounds are going to be, looks like a lower bound and an upper bound. And let's print out, what is this actually doing? This is giving us the bounds of a numeric field, and these are the min and max bound. We can also get the histogram values and the unique values. So let's get the distinct values of, let's get the distinct values of our labels. And in this case, this is doing what in pandas, it would be what unique is doing. So let's use the dot syntax again. If we recall, we have a ground truth field, and we have detections field, and we have a label on that. We get this list of all of the labels, these classes for our detections in our ground truth field. So again, we're applying the dot syntax, Here we're going 3 levels deep, and we're applying it to the label and getting the distinct values for all these labels, the distinct classes that were found within our ground truth detections. Awesome. All right, home stretch. The final stage, pun intended, of this workshop is an exploration of view stages and dataset views. So dataset views are subsets of your dataset. The view stages are the logical operations that you apply to your dataset to get those filtered pieces of the dataset, those filtered subsets. So in some cases, it's pretty intuitive. So you can use something like this syntax to index your dataset. So we can get the samples between index 10 and index 20. This is the same you would do as a Python array, NumPy, whatever else. And so in this case, we're going to get 10 samples. But it actually goes way further than that. And I showed you a pretty complicated example, an illustration of a sequence of view stages earlier. We're not going to go that deep, but what you can do is you can see a list of all of the possible view stages here. So we see there's everything from concat to concatenate 2 views together, or you can exclude certain parts of your dataset. You can exclude by fields, or if you're in a video dataset, exclude specific frames. You can look for when specific things exist. You can filter by geographic information. You can limit to certain numbers of things. You can actually use the direct Mongo information, selecting, shuffling, skipping, and all of this. There's so much you can do, and we're going to go through a few of these, but if you notice, there is this skip stage right here, and there is a limit stage over here. And if we go up and look at the stage, or the subset of our data set that we generated with this indexing syntax over here, the output of that has this little view stages piece at the bottom, which has 2 stages. One is skip and one is limit. So what we've effectively done is we've applied this set of view stages via this syntactical sugar. So we've skipped the first 10 and then limited to the next 10. We can use those directly if we want. So we could do dataset.skip10. And so as a result, we got 190 samples. Our dataset had 200. We skipped the first 10. And we can also concatenate view stages. So here we can just use, again, the dot syntax to do limit of 10. And now we've recreated exactly what we had earlier. So this is the same dataset view as we had earlier. The same sequence of logical operations have been applied. We can also save this. So let's say we'll call this second 10 is equal to this. And then we can actually get this later on here. We could even apply further view stages to this. So let's say we just want to shuffle this. A shuffle is another one of our view stages. Let's shuffle it. So now we have the same samples, but the order has been shuffled. And to see that the order has been shuffled, let's actually look at the values of this second 10. So we'll do the values of the file path here. Or actually, let's do the values. I'm going to clear this. Okay, let's look at the values of the ID. So these are unique identifiers for each sample right here. And now let's look at the values of the IDs for this subset. And we see that it's the same values, just in a different order. So the ordering has changed via our shuffle operation. Okay. Now, all of these are just applied to a field as a whole, but we can also apply view stage operations based on certain conditions. So in order to do that, we use the FiftyOne view field to construct view expressions that allow us to filter and query our data. So we can import the view field. Let's do from FiftyOne, import view field as F. And now let's use that within a view stage. So let's look at our list of view stages again. Dataset.list. Let's look at list view stages. I'll go back up here. List view stage. Okay. And now let's use match. Okay, so what does this match view stage do? Let's look at the docs. The match view stage filters samples in the collection by the given filter. And here we can only include samples with the file path that ends in JPEG, or for instance, with the label of Sunny. So let's do this one. Let's do something like this. So we're going to use this match method. So let's do dataset match, and then let's look at our ground truth. We'll look at the detections within them, and we'll look at the label. And here, let's use this view field. And we'll use the view field and say the list of all of these detections, the labels on them, has to include person. And we get 94 samples here. And this is just one example of what you can do by combining view expressions, which allow you to filter based on manipulated or modified queries of properties into your dataset, with view stages. And once we found this, we can save this to the dataset as a saved view. So let's call this person view, and this is going to be this very similar to the GIF that you saw earlier. Call this person view, and let's save this. So dataset, and then save view, and we'll call this person view, and we'll save this like this. Now if we use dataset.list save views, it shows up there. And additionally, if we go over to the app, and we refresh, when we click on this box over here, we should see person view show up, and we can click on that and get the view that contains only people, or the view of images that contain a person. That's it for the hands-on portion of today's workshop. I want to remind you that what we've covered today only scratches the surface of what is possible with FiftyOne, and I hope that you can use what we talked about today as a springboard to continue exploring FiftyOne and building higher quality datasets and models. Let's conclude with some next steps.